On the morning of September 15th, 1916, German troops defending the French town of Flers-Courcelette heard a strange noise above the regular rumble of artillery and chatter of rifle and machine gun fire, the high-pitched squealing of heavy machinery growing progressively louder. Peering over the edge of their trenches, they beheld an alarming sight, a line of hulking, roaring steel beasts rolling on caterpillar tracks, trundling straight for them. As the British press later reported, when the German outposts crept out of their dugouts in the midst of the morning of 15th of September and stretched to look for the English, their blood was chilled to their veins. Two mysterious monsters were crawling toward them over the craters. Stunned as if an earthquake had burst around them, they all rubbed their eyes, which were fascinated by the fabulous creatures. End quote. A brand new type of war machine had just made its combat debut, the tank. While these vehicles only had a modest impact on the Battle of Flers-Courcelette, this and other battles soon proved the potential of the concept, and over the following decade the tank became an invaluable fixture of modern warfare, providing advancing armies with a potent source of mobile firepower. But for all their advantages, tanks also had the downsides. They were slow, fuel-hungry, and needed infantry support to protect them from enemy anti-tank teams. They also had difficulty crossing certain types of terrain, such as thick brush, swampy ground, and bodies of water. As always, inventors and engineers were quick to come up with various schemes to increase the mobility and versatility of the tank. Some, as covered in our previous video, the surprisingly long and determined effort to create a literal flying tank, more outlandish than others. Rather more reasonable than a flying tank was a swimming one, able to cross marshes, lakes, and rivers, or roll off a landing craft and wade through the surf during an amphibious assault. But even this supposedly simple concept posed a variety of daunting technical challenges, many of which have yet to be satisfactorily solved. This is the story of the long and fascinating quest to create an amphibious tank. The first attempt to create a swimming tank occurred not long after the tank itself made its combat debut. The tank in question was the British Mark IX, aka the Pig, itself the world's first purpose-built armored personnel carrier, or APC, for carrying troops into combat. Designed by Lieutenant G.J. Rackham and built by the engineering firm Marshall, Sons & Co. of Gainsborough, Lincolnshire, the vehicle measured 9.7 meters long and 2.5 meters wide and weighed 27 tons empty. Though based on the earlier Mark IV battle tanks, the Mark IX eliminated the former's gun-carrying sponsons and moved the engine forward, creating a large empty space for carrying up to 50 fully equipped troops. On reaching their destination, these troops would exit through 4 large oval doors on the vehicle's sides. Primary armament was limited to 2 303 caliber machine guns firing forward, though 16 loopholes were provided in the 4 for the troops aboard to fire their rifles through. While certainly ahead of its time, the Mark IX was far from perfect. Its extreme weight gave it a top speed of only 7 kilometers per hour on flat ground, while its lack of sprung suspension or a separate engine compartment quickly made conditions in the troop compartment intolerable. Nonetheless, 34 units were completed before the armistice of November the 11th, 1918, though none never saw combat. That very same day, trials of an experimental amphibious version of the Mark IX, nicknamed the Duck, were conducted in the Welsh Harp Reservoir in North London. The vehicle's buoyancy was increased by strapping a pair of hollow cylindrical floats to its sides, while the track links were fitted with hinged wooden boards that acted as paddles as they passed through the water. The conning tower was also raised and sealed and fitted with a pair of tall snorkels to draw in fresh air and vent engine exhaust and water from onboard bilge pumps. The swimming tests, conducted appropriately by the Navy rather than Army personnel, were successful, though the vehicle was very slow and only marginally buoyant, even in perfectly calm water. The need to seal all openings against water ingress also made it difficult to fit large access doors or heavy armament. The idea was thus abandoned, and the only prototype was scratched. But the task of amphibious tank designers would only get more difficult as constant improvements in anti-tank weaponry forced armor to become thicker and tanks heavier. For this reason, most designs developed during the interwar period were small, lightly armored scouting vehicles or tankettes. Among the most successful was the Vickers Carden Lloyd light amphibious tank, introduced by British engineering firm Vickers in 1931. Measuring only 4 meters long and 2 meters wide, the tiny 1.5-ton vehicle had a crew of 2, a driver and a gunner, and was armed with a single 303 caliber machine gun in a small rotating turret. The hull was streamlined and sealed against water entry, while side-mounted sponsons filled with lightweight balsa wood provided additional buoyancy. The 90 horsepower 6-cylinder engine drove both the tracks and a rear-mounted propeller, giving the vehicle a top speed of 43 km per hour on flat ground and 4 km per hour on the water. Steering was via a swiveling propeller shroud connected to the driver's regular track control levers. Though the vehicle was not officially adopted by the British Army, several were sold overseas to clients such as China, the Netherlands, and the Soviet Union, which used the design as the basis for its own T-37A, T-38, and T-40 amphibious scout tanks. Over 3,500 of all three models were manufactured between 1933 and 1941, the types being extensively used during the 1939 to 1940 Winter War against Finland and the early stages of the Second World War against Nazi Germany in 1941. But while these were among the few armored fighting vehicles of the war capable of easily fording even large rivers, lakes, and marshes, their thin armor made them highly vulnerable to enemy anti-tank weapons, and by 1942 they had been largely withdrawn from frontline service and relegated to training duties. Though purpose-built amphibious tanks like the Vickers Carden Lloyd worked well enough, integrating buoyancy directly into the hull made such vehicles more difficult to maneuver and saddled them with useless weight and bulk once they left the water. Extensive efforts were thus made to develop flotation kits that could be easily installed on regular production tanks and discarded upon reaching the battlefield. For example, in 1939, Vickers introduced a prototype amphibious tank called the L1E3. Designed to cross marshes or lands which had been flooded by the enemy as a defensive measure, the L1E3 was a standard Vickers Mark IV light tank fitted with a hollow sheet aluminium flotation skirt filled with a type of foam rubber known as Armoured. This skirt was divided into multiple independent segments so that damage to any one section would not affect the others. Propulsion in the water was provided by a pair of shrouded propellers driven by short shafts bolted to the rear drive wheels. As the float skirt extended above the driver's hatch, he was provided with a tall periscope to allow forward vision with the hatch closed. But while the system was largely effective and easily installed on any standard Mark IV tank, the vehicle was very slow in the water and still too lightly armored for frontline use. Thus, like the Vickers Carden Lloyd, it was never adopted by the British Army. However, the strap-on floats concept was deemed promising enough to warrant further investigation. In Britain, much of this work was carried out by Hungarian-born engineer Miklos Straussler, a prolific inventor and vehicle designer. Straussler had designed the 39M Kasaba armored car and Straussler amphibious V4 light tank for the Hungarian army before becoming a British citizen in 1933. In the UK, he patented a number of collapsible boats and other flotation devices, as well as the Alvis Straussler aerial bomb trolley used by the Royal Air Force throughout the Second World War. In 1933, Straussler worked with Vickers Armstrong to develop a versatile collapsible pontoon which could be used to build temporary floating bridges across rivers or strapped to the side of a light tank to make it amphibious. Instead of gearing propellers to the tank's main drivetrain, Straussler simply fitted the vehicle with a regular outboard motor. While the system worked reasonably well in testing, it was ultimately deemed unsatisfactory for combat use. Not only did the strap-on floats make the tank too wide to fit onto a landing craft, but transporting enough floats, even collapsible ones, by truck to equip an entire unit of tanks was just logistically infeasible. Yet despite this setback, Straussler wasn't quite finished with amphibious tanks, as we shall see shortly. Meanwhile, halfway across the world, the strap-on float concept was being more successfully implemented. The Japanese purchased a single Vickers Carden Lloyd amphibious light tank for evaluation, and they ultimately decided to develop their own indigenous design. In 1942, the Imperial Japanese Navy introduced the Type II Kami, based on the Imperial Japanese Army's Type 95 Hargo light tank. 7.5 meters long, 2.8 meters wide, and weighing 12 tons, the Kami had a crew of 5 and was armed with one 37mm cannon and two 7.7mm machine guns. Buoyancy was provided by two hollow sheet metal pontoons filled with kapok, a type of plant fiber similar to cotton. These were fixed to the hull via special clips which could be released from the hull, allowing the crew to drop the pontoons after emerging from the water. Propulsion was provided by twin propellers geared directly to the engines, which were fitted by rudders operated by the tank commander. Powered by a 115 horsepower 6-cylinder diesel engine, the vehicle had an impressive top speed of 37 km per hour on flat ground and 10 km per hour in the water. Deployed by the Imperial Japanese Navy Special Naval Landing Force, the Type II Kami first saw combat during the Guadalcanal campaign in late 1942 and was used throughout the Pacific campaign, being encountered by Allied troops in the Marshall and Marianas Islands and in the Philippines. A large version known as the Type 3 Carchi was also introduced in 1943, but never saw combat before the war ended. But while widely considered one of the best designed amphibious tanks of the war, as with many similar vehicles, the Carmi's light armor and armament made it extremely vulnerable to enemy fire, especially late in the war. Given the limited combat utility of light tanks, efforts were made to develop more heavily armored and well-armed amphibious tanks. In 1941, the British attempted to develop an amphibious version of the newly introduced cruiser tank Mark V, better known as the Covenanter. Conceived by the British during the interwar period, cruiser tanks were designed to serve as mobile mechanized cavalry, operating independently and forward of the infantry. Thus, unlike slower and heavier infantry tanks, cruiser tanks sacrificed armor protection for speed and mobility. Indeed, the Covenanter itself weighed only 80 tons, making it particularly suited to amphibious conversion. At first, the British attempted to fit the Covenanter with Straussler folding pontoons, but as before, this made the vehicle too wide to fit on a landing craft. It was thus decided to design an entirely new buoyant hull. Due to the tank's weight and the need to keep the hull narrow, the resulting vehicle, dubbed the AT-1, was comically proportioned, with an enormous lozenge-shaped hull standing 3.5 meters tall. Unlike many previous designs, the AT-1 had no propellers, being driven through the water by its tracks. It also featured a system of ballast tanks fore and aft, between which water could be transferred to keep the tank on an even keel. Weighing in at 31 tons, nearly double the weight of the original Covenanter, the tank was manned by a crew of 5, one of whom was stationed at the bottom of the hull to operate the ballast tanks and bilge pump. While testing revealed the AT-1 to be surprisingly seaworthy, its performance once on land was a different story, with the tank's massive weight and lack of sprung suspension limiting it to a maximum speed of 15 kilometers an hour. Nonetheless, the development of the AT-1 continued until early 1944, when the project was finally cancelled in favour of more practical designs, but more on that in a little bit. Meanwhile, across the Channel, Nazi Germany was taking an altogether different approach to the problem of amphibious tanks. On June 22, 1940, the French government signed an armistice with Germany, completing the conquest of Western Europe, which had begun a month before. With France now secure, the Germans turned their attention to the invasion of the British Isles, codenamed Unternehmen Seelow, or Operation Sea Lion. Unfortunately, the military of the Third Reich had been organized around short-range land warfare and was ill-equipped to carry out amphibious landings. Furthermore, planners were only given 2 months to organize the invasion. Much equipment thus had to be improvised on short notice. As few purpose-built landing craft were available, the Germans instead adapted ordinary river barges for this purpose. Some 2,400 were gathered from around Germany and its occupied territories and modified by fitting them with hinged bow ramps for offloading troops and vehicles and pouring a layer of concrete onto the floor to support the weight of tanks. However, only 800 of these barges were self-powered, and even those had insufficient power to cross the English Channel. All these vessels would thus have to be towed across the channel by tugboats and cargo ships, whereupon the powered barges would beach themselves and offload their payloads. The unpowered barges, meanwhile, would be anchored just offshore and wait for the falling tide to beach them. At the next high tide, tugboats would retrieve the empty barges and return them to cargo ships waiting just offshore, from which they would be reloaded with more men, vehicles, and cargo. Now, you might imagine this extremely convoluted procedure would take a considerable amount of time, and in an amphibious assault, time is always at a premium. The Germans thus placed great emphasis on getting as many tanks as possible ashore in the first wave. Unfortunately, tests revealed that unless the converted river barges were beached along their entire length, the lead tank risked falling off the ramp and getting stuck, preventing the tanks behind it from offloading. The Germans thus decided to offload the tanks further offshore and have them swim to the beach. At first, they took the by now conventional approach and converted 52 Panzer II light tanks into Schwimmenpanzers by fitting them with large Kapok-filled metal flotation pontoons and twin propellers connected to the track drive wheels. However, as with many previous amphibious tank designs, the Schwimmpanzer was too wide to fit aboard regular landing barges and could only be launched from larger vessels with a special ramp cut into the stern. Consequently, the Germans instead opted for a more radical solution, the Tauchpanzer, or diving panzer, a deep wading tank. Also known as the Unterwasserpanzer or U-Panzer, this consisted of a Panzer III or IV medium tank on which all openings, including hatches, vision ports, and gun barrels, were sealed with special rubber coverings. The engine was modified to be cooled with seawater, and the engine exhaust fitted with non-return valves to prevent water ingress, while a bilge pump was fitted to bail out any water seepage. Finally, air for the engine and crew was supplied through an 18-meter rubber hose connected to a float on the surface, which also held the antenna for the onboard radio. Some examples doubles were even fitted with auxiliary fuel tanks mounted on a small trailer to increase their range. The original plan called for these tanks to be transported close to shore by specially modified cargo vessels and lowered into the water by crane. They would then drive along the seafloor and up onto the breach, their crews using a gyrocompass for underwater navigation. Once ashore, the rubber seals would be blown off using electrically actuated explosive cord, allowing the tanks to operate normally. As bonkers as this plan sounds, tests conducted in late June and early July 1940 near Wilhelmshaven showed that the Tauchpanzer concept was basically sound, just not without its flaws. For one thing, lowering the heavy vehicles over the side risked capsizing the crane ship, so it was decided to drive the tanks off the ramps of large landing barges instead. Tests further revealed that if the tanks halted for any reason, they tended to sink into the seafloor mud and get stuck. Tauchpanzer crews were thus instructed to keep moving forward at all costs. It was also decided to land the tanks at high tide so that any which became stuck could be recovered at low tide. Whether the crews would be able to survive underwater that long, that's another matter. But in the end, all of this proved moot, for the invasion was continually postponed and finally cancelled outright on September the 23rd, 1941. Many explanations have been given for the abandonment of Operation Sea Lion, the most common being the Germans' failure to destroy the Royal Air Force in the Battle of Britain. Without air superiority, the invasion fleet would have been sitting ducks for RAF aircraft and Royal Navy warships. And even if the Germans managed to clear the skies and seas, the British had enacted formidable anti-invasion measures and were prepared, as Winston Churchill famously declared, to defend their islands whatever the cost may be. As the invasion of Normandy 4 years later demonstrated, an amphibious assault is an incredibly risky and precarious undertaking, and one which requires a truly gargantuan amount of planning and logistics to pull off. Nazi Germany's amateurish, hastily thrown together invasion plan was almost certainly doomed from the start. And to learn more about Britain's often eccentric anti-invasion preparations, please do check out our previous video, The Badass Story of Dad's Army. But the 160 Panzer IIIs and 42 Panzer IVs converted into Tauchpanzers for Operation Sea Lion did not go to waste, seeing action 1 year later as part of Operation Barbarossa, the Nazi invasion of the Soviet Union. On June 22, 1941, Tauchpanzers of the 18th Panzer Division, fitted with a shorter fixed snorkel in place of the original air hose and float, successfully crossed the River Bug near Pattelin underwater. While Tauchpanzers were considered for use in Operation Hercules, the planned Axis invasion of Malta, this operation was also cancelled in November 1942, and these unusual submarine tanks were never used again. Meanwhile, the Allies were planning their own large-scale amphibious assault, Operation Overlord, the invasion of Normandy. Like the Germans, the Allies wanted to get armour ashore as quickly as possible to support the first wave of troops, and decided that the answer lay in amphibious tanks. Thankfully, by this point, a more elegant solution to the flotation problem had been devised by a familiar figure, Miklos Straussler. Instead of solid floats, Straussler's new system surrounded the tank with a waterproof canvas flotation screen held up by inflatable rubber booms. Following Archimedes' principle, the screen displaced enough water to float even the heaviest Allied tank while only slightly increasing the vehicle's width, allowing it to be carried aboard a regular landing craft. Once ashore, the screen could be quickly lowered out of the way or even removed altogether, allowing the tank to operate normally. Waterborne propulsion was provided by a pair of swiveling propellers driven by the main engine, a system which earns the system the designation Duplex Drive, or DD. The first prototype, DD, was constructed from a Mark VII Tetrarch light tank. Originally designed as a conventional light tank, the 7-ton Tetrarch was later reassigned to the airborne forces and modified for delivery by the giant General Aircraft Hamilcar assault glider. However, none were ever used in this role, and for more on this and other attempts to create airborne armor, please do check out our previous video, the surprisingly long and determined effort to create a literal flying tank. The first tests of the DD-converted Tetrarch took place in June 1941, in the same Welsh Harp reservoir used to test the Mark IX tank in 1918. These tests were largely successful, as were subsequent open sea trials off Hayling Island near Portsmouth. As a result, General Alan Brooke, Commander-in-Chief of the British Home Forces, approved the conversion of a heavier Vickers-Valentine infantry tank to the DD configuration. Testing of the DD Valentine began on May 21, 1942, first in freshwater at Welsh Harp, and then in saltwater near Rye in East Sussex, Castle Toward in Scotland, and Linney Head in Pembrokeshire. While overall the prototype performed well, in November 1942, during live-fire trials, machine gun bullets punctured the inflatable rubber tubes, causing the screen to collapse and the tank to sink. In the wake of this incident, metal stiffening rods were added to keep the screen erected, and with the design perfected, in June the Ministry of Supply approved the conversion of 450 Valentines to DD tanks. However, only 247 had been converted when, in April 1943, it was decided to switch to the American M4 Sherman. Not only was the Sherman more modern than the Valentine, with thicker armor, a more powerful gun, and a hydraulically stabilized turret, but the Valentine's main gun protruded beyond the front of its hull, requiring the turret to be traversed rearwards to fit inside the flotation screen. The Sherman's gun, by contrast, could be kept pointing forward and brought to bear as soon as the tank landed. The converted Valentines were thus relegated to training duties. 2 secret training schools, called Wings, were established by the 79th Armoured Division for training DD tank crews. A Wing, for freshwater training, was located at Fritton Lake on the Norfolk-Suffolk border, while B Wing, for saltwater training, was located at Stokes Bay in Hampshire near Gosport. To simulate the Overlord landings, DD crews rolled into the sea at Stokes Bay and sailed a kilometre across the Solent to Osborne Bay on the Isle of Wight. Finally, training manoeuvres then took place at combined training centres at Moreh Firth in Scotland and Barafundle Bay in Wales. As it was anticipated DD tanks would be used after D-Day for fording rivers, in March 1944 a separate training facility for river crossing was established at Burton upon Stather on the River Trent. By the end of that month, more than 1,200 men had been trained in the operation of DD tanks, but while these exercises taught DD crews many valuable skills, they also revealed the dangerous nature of the vehicle. During Operation Smash, a training exercise held on April 4th, 1944, a sudden change in weather caused 6 Valentine DD tanks to become swamped and sink, taking 6 crew members down with them. In total, at least 10 Valentine DD tanks were lost in training accidents between April 1943 and May 1944. Meanwhile, following the completion of testing in November 1943, 693 Sherman tanks were converted to DD configuration, both in the UK and the United States. While British units used both the M4A2 and M4A4 Sherman variants, American units exclusively used the M4A1. The conversion was accomplished by welding a streamlined metal platform around the hull, to which the waterproof canvas flotation screen was attached. This stood 3.8 meters tall and was held in shape by horizontal steel hoops and a system of 36 vertical rubber tubes. These were inflated from onboard compressed air tanks and could be erected in 15 minutes. At 35 tons, the Sherman DD was more than twice as heavy as the Valentine and sailed with a freeboard of less than a meter below the top edge of the screen. This made the vehicle prone to flooding in anything more than 1-foot-high waves. Another design challenge involved the Sherman's forward-mounted gearbox, which prevented the propellers from being connected directly to the engine. Instead, they were connected to the rear drive wheels, meaning both the tracks and propellers continued to turn at all times. The propellers could be steered by 2 mechanisms, a hydraulic system operated by the driver and a manual tiller operated by the commander, who was provided with a platform on the rear of the turret to allow him to see the flotation screen. Due to the extreme risk of sinking, DD tanks always sailed with all hatches open, while the crew were provided with amphibious tank escape apparatus, or ATEAs, miniaturized versions of the Davis submerged escape apparatus used by Royal Navy sailors to escape sinking submarines. And to learn more about an absurd but tragic disaster involving these devices, please do check out our video, Murphy's Law in Action, the bizarre sinking of HMS Thetis, over on our sister channel, Highlight History. In total, 280 Sherman DDs participated in the Operation Overlord landings on June 6, 1944, the tanks being assigned to 8 Allied units: the American 70th Tank Battalion at Utah, the 741st and 743rd Tank Battalions at Omaha Beach, the British 4th and 7th Dragoons at Gold, and 13th and 18th Hussars at Sword Beach, and the Canadian Fort Garry Horse and 1st Hussars at Juno Beach. The DDs were just one of many specialized and often bizarre tank designs developed specifically for the Normandy landings. Nicknamed Hobart's Funnies after Major Percy Hobart, commander of the British 79th Armoured Division, these vehicles included the Sherman Crab, fitted with a motorized chain flail to clear landmines, the Churchill Crocodile flame-throwing tank, and the Churchill Assault Vehicle Royal Engineers, or AVRE, which fired 18-kilogram flying dustbin bombs to take out heavy fortifications. But all of that is a subject for another video. During the Overlord landings, DD tanks were carried and launched by landing craft, tank, or LCTs, with British vessels carrying 5 tanks apiece and American vessels 4. The DD tanks were to be launched up to 5 kilometers from the beach outside the range of German guns, and the launches being timed so the tanks would land just ahead of the first wave of infantry. Despite the rough weather on the morning of June 6th, over half of the 280 DD tanks were successfully launched into the Channel, though their actual performance was mixed. The greatest success was achieved at the British Sword Beach, where sea conditions were calmer. Only one tank sunk after accidentally colliding with an LCT, while the lead tank aboard another LCT tore its flotation screen, preventing it and the tanks behind it from launching. However, these tanks were later landed directly onto the beach. Conditions were rougher at Gold Beach, forcing the DDs to be launched only 600 meters from the shore. 8 tanks sank, while the remainder landed only to find their assigned targets had already been neutralized. At the Canadian Juno Beach, rough seas prevented the DD tanks of Fort Garry Horse from being launched, while 8 of the 1st Hussars' 29 DD tanks sank before reaching the shore. All units suffered heavy casualties on landing, but eventually went on to make the farthest progress inland of any army on D-Day. Meanwhile, at the American Utah Beach, the DD tanks performed reasonably well, with only 5 being lost at sea, 4 when their LCT was struck by German artillery, and 1 shortly after launch. The remaining 27 managed to hold a tight formation and make it safely ashore, though the smokescreen meant to cover their approach caused them to land nearly 2 kilometers from their intended targets. But at Omaha Beach, the situation was very different. Here, 2-meter-high waves swamped and sank all but 2 of the DDs launched by the 741st Tank Battalion. It has long been assumed that the other 27 tanks sank immediately after launch, but recent research by the Institute of Nautical Archaeology at Texas A&M University suggests otherwise. To quote them here, the landing craft carrying them were drifting away from the target beach, forcing the tanks to set a course which put them side on to high waves, thus increasing the amount of water splashing over and crumpling their canvas skirts. 2 tanks, skippered by men with enough peacetime sailing experience to know not to turn their sides to the waves, actually made it to the beach. It had been widely believed the other tanks sunk almost immediately on leaving the landing craft, but our work showed that some had struggled to within 1,000 meters of dry land. Some stayed afloat for a matter of minutes. According to the crews, 1 tank swam for 15 minutes. Another, quote, "We weren't in the ocean 10 minutes when we had a problem." Tanks at the other 4 beaches suffered no problems. Thanks to quick work by the Navy landing craft crews, all but 5 of the sunken tank's crewmen were rescued from the water. However, the rough conditions forced the rest of the 741st and 743rd Battalion's tanks to be landed directly onto the beach a full hour behind schedule. The lack of immediate armor support for the first wave was one of the main causes of the infamous meat grinder of Bloody Omaha, as depicted in films like Saving Private Ryan. Yet despite such mishaps, the DD tanks, which did make it ashore, proved invaluable to the assault and played a vital role in helping the Allies secure a foothold in mainland Europe. Based on lessons learned on D-Day, an improved Mark II version of the Sherman DD was soon developed. The flotation screen was extended to improve freeboard, a more powerful bilge pump fitted inside the hull, and a second set of hydraulic controls installed at the commander's station atop the turret. The pressurized cylinders for inflating the screen support tubes were also replaced by an air compressor. After D-Day, DD tanks were next used on August 15, 1944, during Operation Dragoon, the Allied invasion of southern France. 36 Sherman DDs of the American 191st, 753rd, and 753rd Tank Battalions were to be launched 2.5 kilometers offshore and make landfall between Toulon and Cannes. 28 were successfully launched, of which 2 sank and 5 were immobilized by landmines. The remainder made it safely ashore, while the 8 unlaunched tanks were landed directly onto the beach the following day. Operation Dragoon was to be the last seaborne use of the DD tanks. Thereafter, the vehicles were used for crossing rivers. On October 26, 1944, during the Battle of the Scheldt, 18 DD tanks of the British Staffordshire Yeomanry made an 11-kilometer crossing of the Western Scheldt River to attack Zuid-Beveland in the Netherlands. While the crossing went unopposed, the tanks were swept far downriver by the current and encountered great difficulty landing on the far bank, with all but 4 becoming inextricably stuck in the mud. 5 months later, on March 23, 1945, DD tanks of the Staffordshire Yeomanry, 44th Royal Tank Regiment, and the American 736th and 738th Tank Battalion participated in Operation Plunder, the Allied crossing of the Rhine River into Germany. Learning from the Staffordshire Yeomanry's experience at the Scheldt, the tanks were launched upriver of their landing sites to account for the current. Landing mats were also placed ahead of time by other vehicles to allow the tanks to climb the river's steep, muddy banks. Though a few tanks sank in the crossing, the operation was otherwise a success. Meanwhile, in the Italian campaign, the British 7th Queen's Own Hussars were equipped with both Valentine and Sherman DD tanks, and in April 1945 successfully used them to cross the Po and Adige rivers. This is the only known combat use of the Valentine DD. The very last use of DD tanks took place on April 28, 1945, 9 days before VE Day, when the Staffordshire Yeomanry used them to cross the Elbe River at Arlemberg. 86 Sherman DDs were also shipped to the British 75th Dragoons in India for use against the Japanese in Burma, but the war ended before they could be deployed. While American armored units made extensive use of Sherman DDs in the European theater, the type was not deployed in the Pacific. This was largely due to the American forces' extensive use of the Landing Vehicle Tracked, or LVT, commonly known as the Amtrax, Gator, or Buffalo. This was a hybrid of a landing craft and armored personnel carrier, capable of landing troops and vehicles on the beach and then driving inland to provide fire support with its onboard guns. Once the LVTs and the first wave of troops had secured the beachhead, regular Sherman tanks would be landed to provide additional fire support. These were often fitted with deep wading gear comprising large sheets of metal snorkels fitted to the engine intake and exhaust outlet to allow the tank to cross the surf. Similar devices were also deployed by other nations, for example, the British Churchill heavy tanks, which participated in Operation Jubilee, the disastrous August 19, 1942 raid against the French port of Dieppe, and these were equipped with deep wading snorkels, while the legendary German Tiger I heavy tank was issued with a similar snorkel for crossing rivers. This proved especially useful on the Eastern Front, as many bridges in Russia could not support the Tiger's weight. However, American forces in the Pacific did make limited use of a flotation system called the T6 device. Harkening back to the Vickers Armstrong designs of the 1930s, the T6 consisted of a set of hollow sheet metal pontoons fitted to the front, back, and sides of a tank. Unlike with the DD tank, no propellers were fitted. The T6 equipped tank simply drove itself through the water using its tracks. On reaching the shore, the front and rear pontoons were blown off using explosive bolts, while the side pontoons were removed by hand whenever was next convenient. Like the pontoon system Miklos Strauss had designed for the British, the T6 made the tanks it was attached to extremely wide and unwieldy. However, the system was more seaworthy than the DD's canvas screen and allowed the tank to fire its gun while swimming ashore. Small numbers were used during the American landings in Okinawa in April 1945. Throughout the latter part of the war, and for several years afterwards, various attempts were made to adapt the duplex drive system to heavier tanks like the British Churchill, Cromwell, Centurion, and Chieftain, though none ever went into service, and post-war main battle tanks soon grew too heavy for such flotation systems to be feasible. However, flotation capability, both integral and add-on, was developed for various light tanks, armored personnel carriers, and other smaller vehicles. For example, both the American M2 Bradley and British FV-432 infantry fighting vehicles were originally designed to use DD-style flotation screens to allow them to cross rivers. Other vehicles, like the American M551 Sheridan and the Swedish Stridsvagn 103 or S-tank and the Russian BMP-1, were designed from the outset with waterproof, streamlined hulls and could propel themselves across rivers and other small bodies of water using their tracks. Still others, like the Russian PT-76, feature both flotation hulls and integrated propellers or water jets, making them fully amphibious. And while main battle tanks are too heavy to actually swim, most are equipped with deep wading gear to allow them to ford rivers. This usually consists of a set of tall snorkels which can be fitted to the engine intake and exhaust vents and the commander's hatch on the turret. In Western tanks, the latter snorkel is typically very wide, allowing it to double as a crew escape trunk in an emergency. Russian tanks, however, use smaller diameter snorkels, making escape impossible if the tank sinks, because of course they do. And that, dear viewers, is the long and fascinating history of the amphibious tank, a weapon which, along with flying tanks, submarines, aircraft carriers, and other wacky weapons we've covered on this channel, stands as a testament to humanity's never-ending quest to ensure that nowhere on Earth is completely safe. Thanks for watching.